Alright, hello everyone, you're welcome to this other video, which is a continuation of the problem solving of the exercises in Math 101. This is the part 2, what you can call module 2. Okay, so it has about 19 questions. We intend to see how far we can go. Probably we'll finish it in this video, or we will know. Alright, so the first one says that if x plus y is 12 and xy is 27, that we should find the value for s cubed plus y cubed. Okay, so and then how do you go about this? So this is a very straightforward thing. Here you are expected to apply the knowledge that we saw under symmetric properties of roots, where we were told that if you have alpha cube plus beta cube, that it was equal to alpha plus beta all cubed minus 3 alpha beta multiplied by alpha plus beta. You see this, I think, in number 17 or 18. Okay, so if we substitute our alpha and beta as x and y, so you see that you get the same s cubed y cubed, and on this side it will be x plus y all raised to the power of 3 minus 3 into xy into x plus y. Okay, so here you have x plus y. All right. And then so you can also do that factorization we did in that number 17, where we brought out x plus y, and then here now you will have x plus y all squared, then minus here you will just have only 3xy. Okay, because this one will go out. All right, so with this you should be able to finish up. Okay, so what do? X plus y is given as 12, so you substitute as 12 into the bracket of x plus y is still 12, so 12 squared minus 3 times xy is 27. Okay, so you multiply by 27, and this is going to be 12 into 12 squared is 144 minus 3 times 27 is 81. And so this is going to give us 12 multiplied by 144 minus 81 is around 63. Okay, so and by the time you do that multiplication, your final answer is going to be about 756. If you use your calculator, that will give you that. Okay, so and that's for number 1. All right, so and we move over to the second one. So here we are told that we should factorize this polynomial. What does it mean to factorize it? To put it in as a product of linear terms, and it is a cubic polynomial, so we are expecting 3 linear polynomials. All right, and there is a hint they gave us here, a very beautiful one, that is if you substitute 5 as your x, that you're going to get 0. So, and this is from factor theorem, that if I have x minus a, that this x minus a will be a factor of this if by the time I equate it to 0 and make x the subject, that if I substitute this a now as my x, that I will get 0. So this is factor theorem, meaning that if 5 is given 0 here, then if we take it over here, it implies that x minus 5 should be a factor of this. And if we have that in mind, it has actually helped us. So all we need to do is to now use that x minus 5 to divide this particular polynomial. And of course, if it is a factor, we are going to see it. So quickly, let's go into it. Let's use it to divide. By the time we finish division, it should be 0 if it is a factor. So, and you know how to do this division. X will be used to divide. So x into x squared, x cubed will give us x squared, and you use it to multiply all through. So x times x, x squared times x will give us s cubed. Then x squared times minus 5 will give us minus 5x squared. And then you will check if there's a remainder. So of course s cubed will cancel this, and minus 3 minus 5 will give us 2. so you bring down your x squared, and it won't be bad if you bring down your minus 9x, and then you divide again. X dividing 2x squared will give us plus 2x, and then again you will use it to multiply. This will be 2x squared, and this is going to be minus 10x, and you will again check if there is a remainder. Okay, so here you are going to have of course this will go minus 9 minus 10 will be minus 9 plus 10, which is 1, so it's going to be 1x. Okay, so it won't be bad again if you bring down your minus 5, and then you divide. Your x dividing x will give you 1, and 1 times x is x, then 1 times minus 5 is minus 5, and so if you subtract you will get 0, 0. Therefore x minus 5 is a factor of this particular polynomial, and that polynomial, the quotient has given us a quadratic function, or a quadratic polynomial, which we can now factorize to get the remaining factors of this polynomial p. Okay, so quickly let's do that. So we now use our normal factorization, which is to multiply the coefficient of x squared with your c, and that will give us 1. So we are looking for 2 factors of 1 that you will add to get 2, and you will multiply to get 1, and that is 1 and 1. So we will just use x to replace here, so we'll just have plus x, and then plus 1. So share them into 2 brackets, you will have something of this nature. Then factorize. There is x here and x here, so I'll bring up x, and when I divide I'll get x here, and I divide here I'll get 1, plus what's the common factor here is 1, so when you divide you get the same thing. And one way, like we said, you will also see all of this in this channel, how to do all this factorization. So one thing we said here is that for you to know that you are correct, that your bracket must be the same. Okay, so and when that happens, you gather what you have outside the bracket and then pick one of the common brackets. And if you watch here, you see that the both of them are the same, so you can as well write it as x plus 1 squared. Okay, and you are done with the factorization. So what it means is that that polynomial, which is your p of x, we don't need to write it again, is actually equal to x minus 5 multiplied by this other 2, which is x plus 1 all squared. And that is the answer for number 2. And straight away we go over to number 3 now. Okay, so number 3 says that we should that if x minus 1 is and x minus 2 are factors of this polynomial, then that we should try to find a and b. Okay, so let's try to do that. Now if they are factors, like what I said about p of 5, so if they are factors, then if you substitute, if you make x the subject here and substitute into this place, whatever you get should be equal to 0. Okay, so and what did we do? If you do that, you will get that x is 1 and then again x is 2. Okay, so now the first substitution will be p of 1. So if we do p of 1, we are substituting here as our x as 1, and that's going to give us 1 cube is 1, 1 squared is 1 times a is a, minus 7 times 1 is 7, then plus b. Okay, so that means our p of 1, I can divide this into 2 here. Let me see. So that means our p of 1 is equal to a plus b. 1 minus 7 is 6. Okay, so I can leave this one here, but remember that p of 1 is 0, so that means this is actually 0. Okay, let's go for p of 2. Our p of 2 is going to be, you are substituting x as 2, so 2 cubed is 8, plus 2 squared is 4, 4 times a is 4a, minus 7 times 2 is 14, then plus b. and so our p of 0 is going to, p of 2 is going to be 4a plus b. Then 8 minus 14 is minus 6. Recall that this is our p of 2, and p of 2 is also 0, and that's actually what they want us to get. So this will fill the blank space there. And then from here you can now form two simultaneous equations, which you are going to get a plus b. Of course, this is 1 and this is 2. So a plus b is equal to 6, because since here is 0, if you transport this minus 6 to this side, you will get plus 6. Okay, so this becomes equation 1, and then from here you will get 4a plus b is equal to 6 also as equation 2. And here we can solve both by simultaneous by elimination method, because we have bb here, so those two can go. So a minus 4a will be minus 3a, b minus b will go, 6 minus 6 is 0, and you are done. Your a is simply equal to 0 over minus 3, which is 0. Haven't gotten our a, we can substitute into any of the equations. Let's do that in equation 1. So a plus b is equal to 6. That means 0 plus b is 6. Therefore, our b alone is equal to 6. Hence, you can say that our a is 0 and our b is equal to 6 as required. Okay, so and that's for number 2. So we'll go to number 3. I hope that will enter this space that I created. Let's see. Okay, so here you are asked to find the remainder when this polynomial is divided by x minus 3. So this will also use the remainder theorem, which is like the factor theorem. So here, if you have x minus 3 as your divisor, just equate it to 0 and you will get x as 3. So remainder theorem says that if you substitute your x as 3 here, that means we are going to have p of 3, and whatever you get is your remainder. That's why in factor theorem, if you substitute it and you get 0, that 0 should be remainder, but 0 means nothing. And so when a number divides and gets 0, it means it's a factor. That's why we call that one factor theorem. So we are substituting our x as 3. I know that some of you would want to go and divide this by this. Of course, you get the same answer, but that's going to take you longer time. So just substitute 3 raised to power 3 minus 7 into 3 squared plus 11 times 3 minus 5. Okay, and you are done. This is 27 minus 3 squared is 9 times 7 is 63 plus 33 minus 5. And if you do this subtraction and addition well, you will get minus 8 as your solution. Okay, so the remainder is minus 8, and that is your answer. Okay, so here we have number 5. So here the question actually says that we should categorize or classify each of these expressions as either a polynomial or non-polynomial. Okay, so how do you know polynomials? Generally, we define polynomials of this way: a n x raised to power n plus a n minus 1 x raised to power n minus 1, blah 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 blah, until you get to a0. So which is the same thing as times x raised to power 0. Okay, so the implication of this is that for a polynomial, your n is actually in natural numbers, so except 0, which is not a natural number. So meaning that your n should be whole positive numbers. Okay, they shouldn't be fractions, they shouldn't be negative. That's the two conditions. And then the third one is that you cannot have a transcendental function. What is a transcendental function? That's functions of trig, functions of log, functions of exponents. So once you have any of these in an expression, that expression is not a polynomial. And then another one is that your variable should be 1. Okay, so you can say a polynomial in x or a polynomial in y not having 2. Okay, so you can see this is a polynomial, this is not. This is a polynomial, the degree is 3, degree here is 1, and all that. Okay, this one is not, because there is a radical, and of course by indices this is going to give you power half. Okay, and finally the last one is not a polynomial, because there are 2 variables here, so you cannot clearly say what the polynomial is in terms of the variable. And then of course you can split that into x over x minus 2 plus y all over x minus 2. So you can see a combination of x and y here, and this one now self will lead you to a degree that is not a whole degree. All right, so that is that for 5. So we go over to 6. So in 6 we are now getting into partial fractions. So here we are to split this into each partial fractions. All right, and in this channel also I've discussed partial fractions, and we said that when you have 2 distinct linear denominators, that is going to give you, or that the number of linear denominators you have will tell you the number of fractions you're going to get. Okay, so this is going to be this, and so you can call here a and here b. So you are looking for the values of a and b, and that's the spaces that you have in your workbook. Okay, so here you can use 2 ways to do this. One is to multiply through by this LCM, or you just look for the LCM here. So let's use the approach of looking for LCM, so which is x minus 2, and by the time we divide, x plus 1 will divide, so you just have a times x minus 2 plus b. The x minus 2 will divide, you get x plus 1 here, and then immediately on both sides this will take away this. Okay, so we just have 4x plus 9 to be equal to a into x minus 2 plus b into x plus 1. Okay, so what do you do next to get your a and b? Remember, there is an approach we use where we eliminate one of the variables here. So we can say let's eliminate b. To eliminate b, then we'll make x to be minus 1, so that here will turn to 0. So if we let our x be equal to minus 1, that will give us 4 into minus 1 plus 9 to be equal to a into minus 1 minus 2. This one will turn to 0. So this will be minus 4 plus 9, which will be 5, to be equal to, this is minus 3a. And so you will get that a alone is minus 5 over 3 if you divide both sides by minus 3. And then again, if we want to eliminate a, then we will let our x to be 2, so that 2 minus 2 will be 0. And so that will be 4 times 2 plus 9 is equal to, here you will now have on the other side, this will turn to 0, so this will be b into 2 plus 1, which is actually 3. And so this is going to give us 8 plus 9, which is 17, is equal to 3b. So our b alone is equal to 17 all over 3. Okay, so this is one way of doing this. So with this, you have gotten your a and b, and you can actually substitute here. Your a is minus 5 over 3, so the 3 should come down to now multiply this denominator. Then plus b is 17 over 3 also, am I correct?